Hi, good afternoon. This is a problem situation, which is measuring electrical variables. The team is by Axel, Daida, Ivan, and Jorge. This exercise involves analyzing, simulating, and implementing a circuit. It consists of several elements connected in series and parallel. The purpose is to determine the voltage and current values in each resistor using three methods that are theoretical analysis, simulation in Tinkercad, and experimental measurements on the breadboard.
For the first part, that is the theoretical analysis, we're going to use the mesh analysis method. The first step is to determine the direction of the current in each mesh. Once we have assigned that, we proceed to build equations using Kirchhoff's voltage law, but in a short and fast method. In this method, we're in the left side of the equation, we're going to write if there's any voltage source on the mesh. In this case, just mesh 1 has a voltage source of 15 volts, and it's positive because the current in that mesh is entering the negative side of the voltage source and is exiting in the positive side. So the convention is accomplished. And on the right side of the equation, the first term is the sum of all the resistors in that mesh multiplied by the current of that mesh. And the next terms are negative because are subtractions. We are subtracting each resistor multiplied by the current of other mesh because these resistors are shared. So we need to write the subtraction of the resistor multiplied by the current of the other mesh that is sharing. We're going to divide the whole equation of that mesh between 1 kilo because the final mesh equation need to be in milliamperes units. These follow equations, and we're going to get a system of equations that we need to solve with the help of a calculator. Once we have the current on each mesh, we proceed to calculate the current in each resistor. The resistors that are not sharing mesh they are going to get the current of the mesh in which they are located. But if one resistor is between meshes, then the current in the opposite way that we designed is going to be negative, and the current that is in the way we decided, it's going to be positive. And the difference is the current of that resistor. Finally, using Ohm's law, we're going to calculate the voltage on each resistor, and these are our results.
So for the problem simulation, the software Tinkercad was used. We used a normal protoboard and the consequent resistors and a voltage source in order to make the simulation. The voltage source was configured at 15 volts.
For the experimentation, we have like the same. We calculate the voltage and the current. Here we have the one of 6.8 kilo ohms. Here for the 18 kilo ohms. Then the 51, the 27, the 12 kilo ohms resistor, the 4.7 kilo resistor.
For this part, as I mentioned before, the mesh analysis was used because in this case the system is planar and can be efficiently described with Kirchhoff voltage law. With this, the equations are obtained assigning mesh currents, and every resistor voltage drop can be expressed using voltage law, as we previously saw. And shared components were modeled correctly using the current difference. This produced a minimal and consistent systems of three linear equations mentioned before, and solving that system, we got the current for each mesh.
Well, now for the equipment implementation, the material that we used a lot in this practice was the protoboard used for build all the circuits and make this type of test. And then the jumpers that are those cables that we use for make the connection between the power supply and the protoboard. And well, later on we use a power supply of 15 volts for give power to all the circuit on the protoboard. And then for making measurements of resistances, voltages, and also the amperage, we use a multimeter. And finally, we use the resistors for change the current or the voltage along of the circuit. Those materials were used to build the circuit in real life for prove the theoretical calculations.
For the lab argumentation, here are the results obtained on the laboratory compared to the results obtained on the simulation. And as we can see, the multimeter does give us the values that we calculated on the Tinkercad. But the measurement result, something important to point is that it is negative because the tips of the multimeter were inverted, but that doesn't change the result. That is the magnitude. And here we can see another result. Something important is that first we got a multimeter that just measured in microamperes, and then we got the right multimeter that gave us the result in milliamperes.
Important is that the voltage is calculated in parallel and the current is in series. This is because if you calculate the series, the current in parallel, it is not going to give you the right value.
So once we made the conversion of the units, we got that the result was correct. Everything was correct.
Well, we can say now that the consistency between the calculated, the simulation, and the experimental results confirm the correct application of the circuit and the appropriate handling of measurement instruments and the reliability of the experimental procedure. Thank you.